Suppose you are a recruiter at a big company and you need to fill in X vacant position for a particular job. However, there are more than X candidates that have applied for that job. Now, each candidate will have a particular skill level which denotes their proficiency in the tech stack that they work with. And each candidate is also assigned a certain ID. As a recruiter, your job is to select the most skilled candidate from this pool and then repeat this process for x minus 1 times so that you always have the best candidates in your company. Now, if two candidates have equal skill level, so for example, if this candidate and this candidate have the same skill level, you will prefer the candidate with the higher ID. Now, can you come up with an algorithm to compute the sum of skill level of all the candidates that are eventually selected? In this example, you can see that since there are 4 vacant positions, you will select the candidate with skill 9 first, then the candidate with skill 5, then the candidate with skill 4, and amongst these two there is a tie, so you will prefer the candidate with ID 4. Can you write an algorithm to efficiently compute this answer? If you have solved some problems on LeetCode, you might consider this a fairly easy problem. In fact, the solution is to sort the list of candidates as per the skill level, right? So you sort the list of candidates in descending order according to their skill, and then you take the first X elements. So all you have to do is write a custom comparator that will sort the candidates on their skill level and take the first X element. The time complexity of this algorithm would be n log n because you are sorting n entries. Now, this variation of the problem is pretty easy. So let me make it a bit more difficult for you. Now, let's assume that the pool of candidates is not static. That is, every minute a new candidate will arrive in the pool. In this figure, the yellow candidates are the new candidates that have just arrived. Now, after every arrival, can you recompute the skill sum of the top X candidates that you would select from this bigger pool? Of course, you cannot sort the entire array again and again every time a new candidate arrives, because the time complexity of that process would be n square into log n, which is too high of a time complexity. So can we do something better? Can you come up with a better algorithm to solve this problem in n log n? I'll give you a hint that it involves heaps. Now can you think about whether it uses a max heap or a min heap? Notice that we always need to somehow track the candidate with the highest skill. So you might naturally think of using a max heap. But as counterintuitive as it might seem, the intended solution is to use a min heap instead. This might seem confusing at first, but once we look at an example, it will be clear why we used a min heap in the first place. So the idea is fairly standard, but a lot of people might not have come across this idea while solving problems on LeetCode. So I'll share the idea with you. So what we will do is we will maintain a selection list. That is, when we have the initial pool of candidates, the ones that we selected were this candidate, this one, this candidate, and this one. And the ones that we rejected was this candidate. So notice that since elements are only arriving, then once a candidate has been rejected, they will never be reconsidered, right? Because new and better candidates are applying for the job each and every day. So we will maintain a list of all the candidates that are selected in a min heap. We'll talk about why did we use min heap in a while. Now, notice that when a new candidate arrives, you will try to compare it with the pool of selected candidates currently. Now, does this candidate have to be the best candidate to be selected? Not really. Because if currently you have selected candidates with skill 9, 5, 4 and 2, the only criteria that this candidate needs to satisfy is it should be bigger than the smallest element that you have selected. That is, it should be more qualified than the lowest person that you selected, right? There is no criteria that it should be greater than 9, and that is why we need to always quickly compute what is the candidate with the smallest skill level that you have selected, because then we can remove or reject that candidate, we can reject the least proficient candidate and replace it with a better candidate that we just got. And since min heap works in log n, that means every arrival can be computed in O of log n. Now let's look at an example for this. Suppose this is the initial pool. Then once you investigate the first 4 candidates and there are 4 vacant positions, you send out an email to all of those 4 candidates that you are currently selected but provisionally. So all of these 4 candidates are selected. Now when you see the next candidate which has a skill level of 4, you amend your decision. You say that, hey, this was the least proficient candidate that I had selected. Now I don't want him anymore. So instead I will select this and reject this candidate. So this is the pool that we currently have. So this is the smallest element which is sitting at the top of the min heap. Then when you see the candidate with value 6, you say that, hey, we don't want this candidate anymore. Let me reject this candidate and take this candidate. And now this has become the minimum. Now when you see a candidate with skill 2, you check your heap again and you say that, hey, this candidate is worse than the worst candidate that we have selected. So no need to select it. So using a min heap, you can solve this problem in O of n log n. Now for some of you, this version might also seem pretty trivial. So let me make it a bit more complicated for you. Now assume that every minute 2 events can occur. Either a new candidate can arrive in the pool or an existing candidate can back out of the interview process. In this figure, the candidates marked red have backed out of the interview process. Now after these events, can you still find out the skill sum of the selected candidates from the latest pool? This might be a bit difficult because notice that right from the start we had selected 9, and to select 9 we had to reject some candidates. But once 9 backs out of the interview process, we need to bring back those rejected candidates. Therefore, it is clear that we need to maintain some sort of waiting list. Now, let us try to think about what that waiting list would look like. So, to do that, we will not directly reject a candidate. We will say that we were maintaining this min heap of the selected candidates, right? So this contained the records of the selected candidates. So we will maintain a parallel box here that will contain all the candidates who were rejected. So we will maintain something called as a wait list. Now how would this waiting list look like? So notice that this was a min heap. The selected candidates list was a min heap. So the waiting list should actually be a max heap. Now this might also seem counterintuitive, but if you think about it for a minute, it is correct, and I'll show you the reasoning why. So the reason why the selection list was a min heap, because there was a possibility that the least proficient candidate that we had selected in the past will get rejected in the future when a better candidates arrived. That is why we had maintained a min heap. But why do we need to maintain the waiting list as a max heap? It is because in the waiting list, the candidate with the highest skill is the most knowledgeable person, right? So that candidate will get the first opportunity to interview again and then land into this selected list. Therefore, if we maintain a waiting list which is a max heap of the rejected candidates, then we can figure out how to fill this void here after this candidate leaves, right? Because the most proficient rejected candidates will have an opportunity to interview with the company again. Now let's dive into more detail of how to handle the arrival as well as the departure of the candidate. So suppose a new candidate arrives in the pool and you already have your min heap for the selection list and your max heap for the waiting list. Now, once a new candidate arrives, instead of doing manual case analysis, what you can do is you can blindly select this candidate, that is add this candidate's name in the selection list. Now if the selection list size has grown to more than x, that is if the number of candidates that you have selected is more than the number of vacant positions that you have, then you can simply reject the least qualified candidate from this selection list. So this candidate will be rejected and it will go into the waiting list. Now this candidate that went in here, this might not be the one that came out, right? But we don't really care. If it is the one that has come out, then it means that its skill level does not match with the selected candidates. But even if it is not, it means that it has now replaced some candidate from here and that candidate should now go into the waiting list. So our job is done. So if the size is greater than x, we will reject the least qualified selected candidate. So this operation can be done in log n because all we are doing is one insertion here, one rejection here and one insertion here. Now how do you handle the departure of a candidate? So what happens when a candidate departures? So once a candidate leaves, so if that candidate is from a waiting list and if that candidate has decided to back out of the interview process, the company doesn't care, right? They can simply back out and we don't have anything to do. We can remove this candidate from that max heap. Now what if that candidate was a selected candidate and they want to back out of the interview process? So if this candidate backs out of the interview process, it means that there is a void, that is there is one vacant position available. Now who is the best candidate to fill this vacant position? That candidate is the most qualified person from this max heap, that is the top element of this max heap, and this is the reason why we had kept it as a max heap. So we'll create this vacant space over here and then we will transfer the most qualified person from here to here, and then this is also just transfer of elements, so this should also work in log n. So now that we have seen the arrival and departure, let's look at the actual code that implements this logic. So first we will write a function that adds a candidate to a pool. So that function takes the skill level and the ID of the candidate, and then if you want to add it, you just blindly select that candidate. So that is why you insert it into your min heap, and then if the size of the min heap grows to more than x, then you reject the least qualified candidate. So the rejection would be the smallest element in the min heap, you reject it and then you insert it into the waiting list. Now here you might see that in the skill sum line, I am not directly adding the skill sum, but I am multiplying it with something else. But this has something to do with a LeetCode problem that I will discuss later. So for the problem that we are currently discussing, if you just write skill sum plus equals to the skill sum of this candidate, it should be fine. But I have not done that, just so that you can reference this code later. Now how do you write the code for removing a candidate? So if you want to remove a candidate, you take its skill and its ID and then you check if it is being removed from the waiting list, then you don't have to do anything. You simply remove that candidate. But if that candidate is being removed after they have accepted the job, then you need to remove that candidate and then you need to fill that vacant position by looking for the best candidate from the waiting list. So that is why from the waiting list you select the maximum element, right? Because that was the max heap, and you remove it from the waiting list and then you add it to the selection list, and this is it. So using just these two simple codes, we were able to implement a complicated interview process. Now if this part seems easy for you, let me add some more variation to this problem to make it a bit more interesting. Now, suppose that every minute one of these three events might occur. Either a new candidate might join the pool, an old candidate might leave the pool, or an existing candidate's skill might change. That is, some people might upskill and they have a better resume now, or some people's skills have degraded over time. Now we have already discussed how to handle these two queries, but how do you handle the skill level change of a candidate? And that skill level change can either be in the rejection list or in the selection list. So take a minute to pause this video and think about how you would handle that. In fact, it is pretty easy to handle it, because if this is the candidate and if his old skill was X and his new skill was Y, to handle that scenario that the skill has either increased or decreased, you can simply back out of the interview process by saying that, hey, this candidate will no longer apply for the job. And we already know how to do that because we already saw the code for backing out of an interview process. And then you can reapply with your new resume, and there you can mention that your skill level is actually Y. And we also know how to reapply because we have already seen the code of how to add a new candidate to the pool. So you don't really need to handle this scenario separately, because you can utilize the add candidate and the remove candidate function that you have just written. So that's why you can split it into two events. One candidate leaves and another candidate arrives. So therefore we can solve all three versions in O of login. Now so far so simple, right? But if you really understand this idea of the interview and the selection criteria for the candidates, and if you have attempted the LeetCode recent contest, the weekly contest, the fourth problem of that contest was actually related to this concept. Now in the next slide I'll talk about the problem and try to think of the connection between these two problems. Once you see the connection, the fourth problem, even though it is labeled as a hard problem, to you it might seem like an easy or at best a medium problem that you can even implement in your sleep. So this is the problem description of LeetCode 3321. Find X sum of all k long subarrays 2. The problem asks you to consider every subarray of length k. So in this figure, all the sliding windows that are colored in green are the subarrays of length k. And then for every subarray of length k, we need to print certain quantity. And how to compute that quantity? So the description mentions that consider any subarray of length k and then construct the frequency map of it. So in this frequency map, the first column represents the value and the second column represents the frequency. So since 2 appears 2 times, so the value of 2 and frequency is 2. 1 also appears 2 times, so 1 appears 2 times. 4 appears 1 time and 3 appears 1 time. And then after computing the frequency map, you need to sort it by their frequency. And if two elements have the same frequency, you should place the element with a higher value first. So 4 and 3 have the same frequency, so we are placing 4 on top of 3. Now once you have done this sorting and ordering of these elements, you have a variable that is X given to you, and you need to select the top X elements from this matrix. That is, in short, in this subarray of length k, you need to pick the top X most frequent element. So you only need to keep the top X most frequent element and then delete the rest of the elements from the array, and your goal is to print the sum of the elements that you have kept. Now try to pause this video and think about how to connect this problem to the interview selection problem that we have just discussed. And in fact, this problem is exactly the same as the interview selection problem, if you can think about it. So let's look at the connection to the interview problem. If this is the array, we'll maintain some equivalence. So what we'll say is, every time we see a value, so this value is 1, value is 1, so we are dealing with values and frequency. Now notice that to compute the answer of every subarray of length k, you can solve it in a sliding window manner. That is, if you have computed the answer for this subarray, then you can think about what happens to your answer when this element enters the window and this element leaves the window. So we can already kind of see the first connection to the interview problem, because it has something to do with a new candidate applying to the pool and an old candidate leaving. But it is not as simple as that. So to make that actual connection, we will say that the frequency of an element in this window will be the skill level of the candidate, and the value would be the ID of the candidate, because at the end of the day you only need to keep the top x most frequent element. So that would mean that there are x open slots. Now you need to keep the top x most frequent element, so that would mean that this candidate has skill 2, that is why it was selected, and then this candidate has skill 2, that is why it has been selected. This candidate had skill 1, but we only had 2 slots, so this was rejected. Now when a window slides, so when this window goes from here to here, let's see what happens. So we are seeing an addition of 2 over here, but this doesn't really mean that 2 has applied to the pool immediately, because 2 might already exist in the window. So if we have already seen 2 before, it means that the frequency of 2 has increased, that is, the skill level of the candidate with ID 2 has increased by 1. But if we have not seen this 2 before, that would mean that a new candidate with frequency 1, that means skill 1, and IDS 2 has applied for the job. Now what about when a window slides and this element goes out of the window? Then once 1 is out of the window, it means that the frequency of 1 decreases, that is, the skill level of the candidate, this candidate, it decreases by 1. Now if this 1 is not present in this new window anymore, we will say that this candidate has backed out of the interview process. But if it is available in this window, we will say that the skill level of this candidate has decreased. So the skill level of candidate 1 decreases from 2 to 1, while the skill level of candidate 2 increases from 2 to 3. So all you have to do is convince yourself that this mapping, that frequency maps to the skill level of the candidate and value maps to the ID of the candidate, is a proper mapping. That is, once you do this mapping, this problem is 100% same as the interview selection problem. Now you might think about how to even make the connection of this with the interview selection process. Well, that comes from experience, and since I have solved similar problems such as median in a stream, I was able to immediately see the connection, and I'm pretty sure you will be able to see the connection as well once you have solved a good number of LeetCode problems. So now your original problem also asked you to print the sum of all the elements that you have kept. Now how do you track the sum? So notice that the skill level was the frequency, and id was the value. So to track the sum, if you look at this figure, all you have to do is multiply this with this, because this says that 2 appears 3 times. So 2 comma 2 comma 2. So that would mean that the sum is 2 plus 2 plus 2, which is nothing but 2 into 3. Similarly, this is 4 into 1. So if you do skill level into candidate id, that would give you the sum that you are looking for. And that is the reason why I had kept this as skill level into candidate id. So whenever you are inserting something to the selection list, you increase your skill sum by this amount, and whenever you are taking out something from the selection list, you decrease it by that same amount. And the time complexity of this algorithm would be n into log x, because every time an event occurs, that is every time a window slides, all we are doing is just some transfer of elements from a min heap to max heap and vice versa. So this is the code for this problem. We have already seen the code for how to add a candidate and remove a candidate. Now all we have to do is write the actual code for changing the skill of a particular candidate who was already selected in the past. So we iterate over every element, and then let's consider the ith element. So the ith element will be the one that is entering the window. So if it is entering the window, we need to check if it was present in the window before, because if it is present, we need to remove it from the window. Because remember that to change a skill level, you decided to split it into two halves, right? You reject the candidate and then the candidate will reapply with the updated resume. So if that candidate is already present, you reject it, remove it, and then the skill level of that candidate will increase, and then you can add that candidate, and this add function will take care of where to add that candidate, whether to add it in the selection list or in the waiting list. Now we also need to look into the candidate that will go out of the window. So that is this candidate, right? So once that candidate goes out of the window, let us remove the skill, let us decrease the skill level of this candidate. To do that, first let us remove the application of the candidate and then decrease the skill level and then add that candidate back. But if after decreasing the skill level, if the skill level has become 0, it means that the candidate has backed out of the interview process, so we do not need to add it anymore. And then you print the skill sum which is already being tracked in your add candidate and remove candidate function. Now you see that just by abstracting out things, you are able to solve a hard LeetCode problem with a pretty simple code. And I hope this also showed you the powerful application of heaps, min heaps, max heaps, sliding window, and how to actually use sets in C++ to simulate a heap, because that is my preferred method. Now if you liked the content of this video, you might also enjoy a problem called median in a stream of integers, which is where I got the motivation of maintaining these two heaps from. So this min heap plus max heap trick is not something that I've come up with myself, but this is something standard but not well known to many. So you can try to solve this problem on LeetCode. And all the code and slides for this problem will be available on cfstep.com, and I will also link it in the YouTube description. If you like the format of this video, do let me know in the comment section down below so that I can try to add similar content in my channel in future.